Hello, everyone. I hope you are doing well. Welcome to everyone. Uh, so you got a bunch of people active in chat. Got a lot of penguins in chat for Zach. I did not ever hit that button. Uh, Last time, I wanted to say we set this puzzle. So we're not going to solve this puzzle today, but we set this one last time that we were here. And so this is going to be published on LMD, I think today. That is my plan. We'll see. It might be tomorrow, but anyway. So if you like to keep up with the puzzles that we set on stream, this will be out soon. I am quite happy with this. I think this is probably on the easier end of what we said, although probably still 3 stars based on tester feedback. But anyway, if you're into this sort of thing, you can look for it. And if you are eager to do it now, it is in the Sudoku testing place on Cracking the Cryptic. So you can always go do it. But our puzzle that we're actually going to start with today is this one. So as always, we start with the puzzle that has gotten the most votes from supporters, which today is this one. And so today this puzzle was voted for by David, Plonktime, MaizeGator, Russ, Afraid Not, Nell, Luda, and Nordy. So thank you all for your support. I hope you enjoy this. It looks daunting but interesting. So let's read the rules. So normal chaos construction rules. So we need to place the digits 1 through 9 into every row and column. And also region, but we aren't told what the regions are. So we have to find the regions. And note in this puzzle, no 2 regions may have the same shape, including rotations and reflections. So I welcome chat to scan for that, because I'm going to forget that rule, and it can't possibly be relevant until way later in the solve. Normal nurikabe rules apply, so we need to shade some cells blue, representing water, and some cells such that all water cells are orthogonally connected, but water may not fully cover a 2x2 area, and shade the remaining cells green, which represent islands. Each chaos construction region contains at least 1 nurikabe island, while each nurikabe island must be contained within a single chaos construction region. No 2 nurikabe islands may have the same number of cells. Okay, so I guess that means that there's 1 region with 1 region with 2, 1 region with 3, and so on. Oh, at most 1 nurikabe island, sorry. There can be an entirely water region. If a cell with an arrow is water, the digit indicates the distance to the nearest island cell in the direction of the arrow. And if a cell with an arrow is island, the digit indicates the number of cells in the island, and the direction of the arrow is irrelevant. An island does not necessarily need to have such an arrow. Okay, so that is crazy. Okay, so for example, if this is water, it means that's water. And this would be a 1. Okay, so I think what's going to happen is these can't both be water and they can't both be land, is I think going to be the point. Because if these are both water, then this is going to happen. That's going to have to be a 1. Oops, my number pad's not on. That's going to have to be a 1. That's going to have to be a 2. Oh, maybe actually, sorry, that's going to make all of that water. Sorry, I thought that was going to make a 2x2, but it doesn't necessarily make a 2x2, does it? They definitely can't both be land, though. But I guess actually the world where they're both water is actually a little bit plausible. Oh, it's distance to an island. Sorry, it's not the number of water cells. It's the distance to the island, which I interpreted as the number of water cells, but is not. It's not that. It's one less than that, or something like that. Yeah, it's off. It's off by one from the thing I was doing. I think it's one. So if this is water, what it means is that this is land because it's a distance of one there. Wait, it is the number of water cells? Sorry, let me reread the sentence. Yeah, so right, so if this is water, this is land, and that's a 1. And I know one of these is water for sure, because they can't, anytime that two things touch, at least one of them has to be water, because your lands can't touch. That's just nurikabe rules. So it is true that one of these 3 cells at least is land. For whatever that is worth. If this is water, it's a 1, and that's land. Let's see. Yeah, we've got a lot of things where it's sort of like, if they are a thing, then yeah, so Selena, I think, wants to say that should be a 0. Or sorry, if I reverse those, I did those backwards. That this should be a 0 because it's a distance of 0 from here to land. I think it's probably intended to be a 1, but it could be more clear. So I think it does count itself, but I'm not 100% sure. But if this would have to be a 0, of course, it would mean that this arrangement wasn't possible, but I'm pretty sure we're intended to interpret that that's a 1. Let's see. So can do that. Let's see. Oh, okay. Garion says the thing I was trying to prove over here is actually true over here, because they can't both be land. And Garion says they can't both be water either, right? Okay, so, right. So if they were both water, that doesn't work because this would just be undefined if they were both water. So, and they can't both be land because of nurikabe rules. So we know there is a divide of some sort between these. Okay, so I'm going to make 1 yellow and 1 purple, just for sake of this. If this is water, yeah, one of these cells is definitely a 1, is worth noting, because one of these is water pointing at land. Yeah, and so what that means is that this cell, we know what it is, because this cell now can't be water. This cell has to be land. So we can go ahead and fill our land in here. And so now the arrow is irrelevant. And so this is water because you can't have 2 lands touching. And so it has to be a 2. And we get to do our digit dance. Ba-doop, ba-doop. duka, duka, ba-doop, ba-doop, duka, 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 ba-doop, ba-doop, duka, duka. Woohoo! Ba-doop, ba-doop, woohoo! Ba-doop, ba-doop, woohoo! Thank you, Zach. Thank you. And so that means that is water and that is land. I said that is water, and then I filled land in it. So we've got that happening. And this is not a 1, or a 2. So we know these are both green as well, because remember, this is the size of the island. So we know those are both green as well, because we know this is now at least 4 because of the stuff that we have floating over there. So we've got that. Let's see. Right, it can't take this arrow because that would be repeating a digit in a column and in the region. But this could maybe come down here like this, huh? So I don't actually yet know. Oh, no, it can't do that because that would make it size 6. That's cute. This is either size 4 or 5, because without taking a second arrow, these are the only cells it can take, but it can't take all of them because then we'd repeat 6 within the region. So this is always a 4 or a 5. Now this arrow is either a 1 or a 2, and this is definitely water, right? Oh, no, sorry. No, that's not. Oh, actually, it is true, I think, that it's a 1 or a 2, because if this is land, it can't take an arrow, so it would be a 1. And if it's water, it's a 1 or a 2. So this cell's always a 1 or a 2. Regardless of how that happens to work out. Let's see. Annoyingly, these can both be land, I think. Okay, so if this is water, yeah, then there's a couple options. Okay, we do have this arrow that is on water. So, I mean, I guess that leaves there being some options, but not an enormous amount necessarily. It'd be really nice if I knew that this couldn't be land, I guess. Oh, okay, right. So, Garion points out, if this is the 1 of water, it's a problem because now this has to be of size at least 3, but it can't be because of growing from the arrow. So this is not the 1 of water. This is the 1 of water, meaning that this is the land. And now, by connectivity, the water has to get out. And now this region is at least of size 3. And it doesn't take that because it would be a second arrow. So it does take that because, again, it's at least of size 3. This arrow now has to be land because if it was water, it would be a digit that already appears in the row. And it's land, and it's not the same land as that one, so that makes that water. This, again, is at least of size 3, so it has to grow. The water has to connect, so that has to grow. So that gives us some chunk of these things. Let's see. Yeah, this also has size at least 3. That's true. It has size at least 3, but it actually has size at most 3 as well, because there's only 3 things it can possibly take. So this is a 3, and it takes those cells, and this island is done. I don't know how I sort of want to denote that, or if I want to denote that. That makes that water, which makes this land by nurikabe. This is water. by rules, and as a water cell, it's a 3. This is water, again, because of the not repeating an arrow was the spirit of all of that. This is water because of connectivity. This is green because now this can't be of size 3 anymore either. Hey, DDX, how are you doing? That makes this also a 1, just by the definition of water. This is a 1 by the definition of water. Or the definition of water arrows, I suppose I should say. Okay. Okay, so this needs to get exactly 6 water cells to go with it, I guess is one thing that we can say. This region, these two aren't in the same region. Oh yeah, this has to be a 2. Thank you, Jay. Because it's not a 1, and so it's a 2, which means that is also water. Good. Annoyingly, I don't know that this has to grow because I don't know that not every island necessarily has a clue. Let's see. Oh, this can't be water because if it was water, it would be a 3. So this is land, for what it's worth. So this is water. Okay, so it is actually an island of size 1. So we've got that. So this is a 1 or a 2, and it's not a 2. So this has to be a 1, which makes that land. And now this can't be land because of the previously noted statement that would make it size 6. So this is, in fact, a 4. This island needs to grow because we have our island of size 1. This water needs to grow because water has to get out. This is a 2 by the definition of water. This can only be a 1 or a 3, I suppose. Let's see. Okay, so now one of these two has to be water. Actually, this is a water-land pair because by connectivity I need a water, but they can't both be water. And I know this is at least 5 now. Oh, if this were water, it would be an infinity, so that doesn't work. So this is green. And it's not the same island as this, but this island needed to grow, remember? So that's definitely part of this island, and the water needs to escape. And now this water also needs to escape. This water needs to escape. Sorry, wrong color. This island needs to grow. This island needs to grow. This is at least 5. Regardless of how things go. Okay, well, this island can't be of size 2 because of Sudoku, so this island grows, makes the water grow, means this can't be a 3, so this has to be a 1. Uh-oh. No, it has to be a 3. Sorry, it has to be a 3 because it can't be a 1. Sorry, I miscounted how that worked. So this island still has to grow because it's not done yet. This digit, if you count, it's at most 3, but it's not 2 or 3. So this digit has to be a 1, which means that has to be land. These have to be water because all the water is connected. That has to be water because all of the water is connected. That has to be water because all of the water connects. Okay, this needs to be a minimum of 4, and so that means that these are blue, because this can't be a 1, 2, or 3 just by Sudoku, so none of those can be land. Let's see. Where is there an island at risk of taking a second arrow, Selena? I don't see that yet. I agree it's true, but I don't see where it is at risk of doing that. Oh, I have a 2. I have a 2. I didn't realize it, but I made a 2. So this needs to grow. This is at least, and it can't be a 3 either. So this grows again. That makes that there. Makes that a 5. Makes my water come down here because of connectedness. This island needs to grow at least 2 more because we've got our 1, 2, 3, 4, and 5 island. Oh, DDX donates. Let's get you a donation dance. Boop boop doop boop 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 boop. Woohoo! Boop 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 boop. Woohoo! Woohoo! Thank you, DDX. DDX asked if I got sunflowers. So I planted a ton of sunflowers. I successfully got one DDX sunflower that survived the deer. Ooh, your 10th. Then that was your 10th super chat. Thank you. Huge thank you to DDX.
Sunflower.
Huge thank you. Greatly appreciated. But yes, sadly, my sunflowers have been a bit of a tragic affair this year. But the one, at least, I'm excited about. Okay, these need to grow. And now these arrows need to point at land. That land certainly needs to grow. This is a 4. I really like sunflowers, so I am a little bit sad about it. These grow. Because it's got to connect. 1, 2, 3, 4, 5, 6. Okay. But this can't have size 6 because it sees the 6 by Sudoku, so this has to grow. This has to grow. This water has to grow. So this can only be 7 or 8 because it's at least 7, but it sees a 9. This still has to grow because we've got all those sizes. This is a 1. This is a 2, just by counting. Oh, this isn't a 4, so this island has to grow, and it's not a 5 either, so it has to grow again. So that is... Okay, so this can't be water because if it was water, it would be a 2. So this is land, and it has to grow. So that has finished that this is a land of size 9, which means these are both water. Because we already have an island of size 5 AFK. So... Okay, so if this was water, this would be a 3, so it's not, so it's land. So that is water, and this works out to be an 8. This works out to be a 6. We certainly know this down here is a region. I can border the outside here. I'm a little afraid of what the chaos construction element of this is going to look like. That's going to be a 1. That's going to be a 4. It's going to be a 5. So we've got all of those. Okay. So I know that this land of 3s does not take that 3 at least, so I know that that is a border. I'm trying to think what I can do with these double 1s, but I don't quite know yet. One region is only water because we only have 8 islands. That is a good thing to know because we never ended up with an island of size 7. Is a good thing to have in mind. And the island that's only, or the region that's only water can't be a horizontal line because we can't have two lines being the same size. Yeah, that's a good way to put it. One of these has to join the 5, because if neither of them joins the 5, they join each other. So one of them joins the 5, and whichever other one it is, definitely sort of comes down through here, is Jay Dyer's point. And that has to be the region that's only water, right? Because this region now has size at least 4, and there's no way it is going to get there without having problems if I try and add, like, I can't add an 8 to it. So yeah, so this is the region of only water for what it's worth. Let's see. Do I have it digits don't repeat on... Oh, yeah, I know digits don't repeat on islands because islands are entirely contained. So the 4 in column 9, for example, is what I'm looking at. It only has 2 places it could possibly go. Yeah, so this region needs to take more cells in column 1 because it's going to be 1, 2, 3, 4, and it could take 5, 6. So it's going to need at least 3 more cells going down this island. Like that. Oh, if it takes this one... Oh, no, sorry. I'm about to say it makes it really hard to put 1 in column 1, but column 1 already has a 1, so that's not relevant. Let's see. Okay, how is this 3 region getting enough water? Given it's not taking this cell. If I don't take that 2... Oh, if I don't take that 2, maybe I can get just enough water. Only just, though. It's getting very tight. It would be nice if this 4 just took all of that, because that would get us to 9. Let's see. So 1 here, and here, here, and here, here. Those are sort of the 2 1 options. Yes, the 4 can't take both 2s. But I fear that doesn't immediately tell us that it doesn't do something like that. Although there's definitely some geometry stuff happening here. Yeah, the 3 region definitely doesn't take both 2s. That's why I was looking at it, but it can't take the 3 at all, and it can't take both 2s. But I don't have anything to do with that yet. Yeah, in terms of water this 5 can take, it's going to take the 1. It needs 3 more cells beyond that. Right, so the 8 region definitely doesn't take the 4, Jay Dyer points out, because if it did, it would become 10 cells. So that is a very worthwhile note. So this is in a region which is the same region as that cell, at the very least. And so this needs to take exactly 1 more cell somewhere, exactly 1 water cell. So if that isn't a 1, then it takes like one of the 1s, like that 1, for example. Let's see. This is only going to get 3 more. So I know, I guess I can draw in that bar, for example. Oh, okay, that's the point. That's the thing I'm supposed to look at. This cell, what happens to this cell? It can't join the 6 island. So if this cell tries not to join the 6 island without taking the 4 island, it's definitely going to become a second all-water region, and I can't have a second all-water region. So in fact, the 4 region definitely takes the 6, at the very least. Which is, which feels like something, maybe, possibly. Let's see. Okay, and I still need one of these two to be the 4 for the column. Oh, the 8 for column 2 is also pretty restricted if I am looking at that kind of thing, because the only places it can go are those two, because there's a random given 8 here. Let's see. And the 6 in column 7 is getting a little bit cramped, depending on exactly what we do with this 4. It seems like it would be really easy to just have this 4 run down that side, which would be quite annoying, if I'm honest. But I don't quite know what to do with it. Let's see. This 2 island can't take that 2. I don't think that quite immediately tells me anything. The 6 needs to take 3 more things. Is there anything it definitely doesn't take, given that it needs to take 3 more things? This 1 is actually pretty tight because of the 6 region and the fact that it doesn't cleanly join the 6 region. I guess it could cleanly join the 6 region like that, maybe, or something. Awkward. Let's see. Okay. Oh, is the 4 in this region just placed? Oh, not quite. Because these cells can't be 4, that can't be a 4, that can't be a 4. So either one of these two is a 4, or one of the cells this grabs is a 4. Yeah, it's going to need to be resolved by the fact that 2 regions can't have the same shape, J. Dyer, is what I think is going to happen. And that's going to be horrendous, because I think ultimately we're going to say something like, oh, I already have one of those, so this region can't look like that, or something like that. It is a very weird rule. I'm still trying to sort of scan for Sudoku on digits to see if there's any digits that are interesting in terms of where they have to go. Which means the 2 is with the 4. Yeah, okay, so it's even true of this cell, right? Because like the yeah, the 1 joins either the 4 or the 6. These all join the 4 or the 6. I think even that one's going to have to join the 4 or the 6. Although maybe there's some crazy world where 1, 2, 3, 4, 5, 6, 7. No, I think this one too. then I think this one could do that crazy thing or something like that. Because these two are in the same region, I think that one still can't. So I think this is actually definitely part of the 6. Because if I try not to, then I think I overflow by 1 because of that. So I think we can say these are definitely part of the same region. And the 1 is definitely also... Oh, sorry, no. The 1 is not definitely also part of that region. Sorry. But if the 6 region takes the 2, this was David's point. If the 6 region takes the 2, it makes the 6 region take all of these cells, and now the 6 region is too big. So the 2 actually has to go with the 4. And in fact, similarly with the 3, actually. And so what that says is that this 2 definitely doesn't join the 4 region. For whatever it is worth. Oh, and this 6 definitely takes... Oh, sorry, no. The 6 doesn't definitely take this 1. Sorry. Am I supposed to ask an annoying question about if this digit is 4? Where am I putting the 4 in the 8 region? I think there'd still be a possibility to like smuggle it in one of these cells, or maybe even that cell. I don't think it's quite there yet. But we're getting close to being able to say that kind of thing. I think the 4 island can either take that one or that one. As far as I can tell. Maybe I should start like marking things. I don't know if I have all the digits yet, so let's see. So this is not a 1 or a 2. Could be a 3 or a 4. Can't be a 5 or a 6. Could be a 7. Can't be an 8. Could be a 9. Okay, so I think if I do that, I think I can start randomly marking cells. And that might be insightful. Oh, okay. So this is a good spot from Selena. So we know that this region currently has 6, 7 cells in it, depending on which one it takes. So we can only have 2 of these possibly get eaten by this. So this is definitely part of either the 8 or the 2. Which means that this is Selena's point. This is definitely part of the 2. Because if this is not part of the 2, it can't be part of the 8 either. And it can't be part of the 6 because the 6 already has too many things. So this cell is going to have to run up here and be part of the 2. So we're going to end up with that, which is, I think, going to mean that that cell's also part of the 6 region, right? Because now now this is going to take 3 more. So this has 1 cell to give. I think row 8 column 2 can be part of the 8 region, Garion, because I think this region, I think, can still take that cell. The 8 region can take that, but I think I agree that cell can't possibly be anything else. Because this cell can't join there. Let's see. So, So I guess what I know is that 3, 4, 5, 6, 7. Uh, uh, yeah, this 1 needs to join the 8 or the 2. I agree. It doesn't have any other choices. If it does join the 2, then I know the region looks like this. Let's see. So therefore the 8 can't take... yeah, okay. So actually Jay is right. The 8 can't take this cell because if it does, that then forces the 2 region to take both of these, because it now becomes the only region that can claim either of them. And that's a problem because now it's already at its destined number of cells and it's not connected yet. So, in fact, actually, Garian's point before was correct. The water island coloring does do something because I know these are all in the same region. I guess you could just replace each water island with like a start of a region or something. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, yeah. So actually, yes. This is the last cell of this region. Because we know it's got a 1, it's got these 7 cells, and then this one. So actually, this region, we actually know all of this. And so it's going to take one of these 2 1s, and so it takes that 7. So that's where it gets its 7. That's not a 7. The 5 region is definitely taking one of these. 6 column 3. Yeah, okay. So these 2 cells, so Selena and J40 are sort of teaming up to tell me these 2 cells can each only join the 2 island or the 8 island. And so that gives me the totality of these things aside from that. So in particular, that means the 8 island does not take this stuff or that or that or that, because the 8 island's going to take one of these 2. Of course, it doesn't take these. The 8 island's going to take one of these 2, and the 2 is going to take one of these, and the 2 is also going to take one of those 2. But then the 2 island's going to be done, so it's not going to take any of those cells. Which means these are part of the 5. So the 5 island now has 8 total cells because the 5 island's also taking one of the 1s. So the 5 island only gets 1 more cell, regardless of how that goes. Oh, right. I know this doesn't take this anymore by the previous Selena argument. I know this is a different region. So now actually this seems very relevant because now this cell is definitely part of this is definitely part of it. So actually the 6 region's done because that's actually forced there. That was where Selena wanted me to look. So all of this is actually the 6 region, and that region is done. So that means the 4 region really does look like this kind of silly little sort of runoff over here. It means this really is a 4. Let's see. Yes, the 6 region needs a 1, which makes these 1s. And now the 8 region needs a 1. And we noted it's not that one, so it's that one. And so now the 2 region claims this cell together with its 1 more cell. And it needs a 1, actually, and all the 1s are in the grid, so the one it gets is that one. Oops. So now that region is done. So we end up with these are all part of the same region now. And this region has a 1, so it does not take that 1, which means these are all part of the same region, which means there's a region border here. Which means this continues out here. And this now has to take the 3. Take the 3 region, because if it doesn't take the 3 region, it can't finish, which means it can't take this, so that does. So we've got all of that. 1, 2, 3, 4, 5, 6, 7. Okay, so that is actually a finished region. That is the 8 and the 9 to finish that. Oops. 2, 3, 4, 5, 6, 7. Okay, so this needs 2 more cells, and the 5 needs 1 more cell. So the 5 can't take that cell, I guess, is one of the points. That cell's definitely not part of the 5. So it's definitely part of this 3 region. And it's just a question of whether this 3 region ends up taking the cell above it or below it. Right. And so this region can't take that 1, as being pointed out, because that would give the same shape. So we actually now know how that works, at least. And so it's just a question of which of these is the last cell that we get in that region. Oh, this region I can get rid of all of the stuff because this region is done. Let's see. I did say 4 was pretty restricted, so yeah, I know that 4 is in one of those 2 cells for whatever that is worth, and then I'll hit 7 instead, which will just make it seem more exciting. Okay, let's see. Yeah, 2 in this region has to go there. Selena points out. Because I know one of these is the last cell of the 5 island, and neither of them definitely neither of them takes definitely neither of them is 2. There we go. That's the words I was trying to say. Okay, neither of those can be 2. That cell can't be 2. So one of these 2 is the 2 for the column. And it's not that one either, actually. So the 2 in column 4 is just there. That one can't be a 2 because it's in a region that already has a 2. So that's a 2. Okay, where else can we place 2s? If anywhere. Let's see. Yeah, so now where is the 2 in column 2? The 2 in column 2 is now there. Agreed. Okay, and then we've got our little mini pattern of 2s go in some of those places. Let's see, Nemafish says this is an 8. Right, because this region needs an 8. Do I know that's not an 8? How do I know that cell's not an 8? Let's see. There was some discussion of 4s. Yeah, so 4 is actually placed because of that 4. 4 is placed in this region because of the 4 corner mark there, so that's a 4. So we have that. That's a lot of 4s in the grid for what it is worth. Oh, because of row 5, right? Row 5 needs an 8, and it's got to be one of those two. Oh, sorry, no, it's got to just be that one, right? Because there's a given 8 there, so that is an 8. Agreed. Thank you, Nemafish. Let's see. So 8 now in row 6. Well, I guess I can say, first of all, 8 in this region goes in one of those two places only. I don't know that that's going to help at all, but maybe it will at some point. Okay, 3 in column 7 goes there per Garian. Both of these regions already have a 3. And so those are a 7 and a 6. These cells and these cells we can just go ahead and mark up somewhat shamelessly. Let's see. Okay. Right. This 6 is in the same region as this, so that's a 7, an 8, and a 6. Let's see. Okay. I was encouraged to remove a 3 from that cell. This region already has a 5. Let's see. Let me fill in the quadruple that is over here. We still need a 2, 3, 4, 5, 6, 7, 8, 9. So this is my quadruple. So these are everything but those. So I got a 1. I've got a 2. Still need a 3. Okay, so the 3 in the column goes there. Still need a 4. So no, sorry, don't still need a 4. 5, 6, 7. Still need an 8. So the 8 in the column goes there. So that digit is an 8. Now I certainly am willing to mark these cells. This digit is a naked 5. Makes that a 9. Makes that a 7 and a 4. Okay, so the digit that this needs is a 9. So therefore, that's the last cell in the region. And we can fill that in. And we can get rid of all of that. So we finished our regions at least. Let's see. This region is missing a pair of things. Or sorry, no, this region is missing a triple of things. But 5 and 7 aren't among them, so this is just a 9. 2, 3. Okay, we still need a 4, and it apparently goes there. We've got a 5. We still need a 6, which apparently goes there. We can fill in these cells, so that's a 5 and that's a 9. Let's see. We can fill in all of these cells. I know one of those two is an 8, so that isn't. So this is a 5 or 6. So those are a 7-8 pair, which means that when I go ahead and mark these up, they aren't 7 or 8, which sadly did not immediately help me. However, this region already has a 9, so that's a 3 and that's a 6. Is not a 3. This column now, that is a 3 and a 7. Let's see. This row, that all seem like candidates for marking. So this seems to be a 5 and a 3, and a 9 and an 8, and a 4 and a 7, and a 5 and a 3, and a 4, and a 5 and a 9, and a 7, and an 8 and a 7. So now I think we can just mark everything. And get a 2, 5, 8, 9, 6, 9, 2. Very nice. Usual caveats about how, like, the back third of this was the region building. I would have just made this a Latin square. I think, honestly, you could have just made this a Latin square and said digits can't repeat on islands, and I think you could have made this sort of work without having to include the sort of awkward region building at the end, because the region building wasn't really connected to the nurikabe part of the puzzle. So I think you probably could have gotten away without having to do that. It's always tricky, or like make it a JSUMs puzzle or something like that. But very cool. I enjoyed the arrow logic was really cool. All right, I'm going to take a quick break, and I'll be back in a minute with more puzzles. So see you shortly. All right, welcome back. Let us do this Ratfink's puzzle. So we have rules here. So we have normal Sudoku rules. We have 10 lines. Digits along gray line must be separated into sequential groups so that each group sums to a total of 10. Okay, so we have some X's and then one giant 10 line. Arrows. Right, so the arrow, these are arrows. The sort of ends get clipped off, but the sum digit in the circle is the sum of these two, and likewise for the others. And then we have entropic lines. So along these entropic lines, any three consecutive digits need to have a number from 1, 2, 3, one from 4, 5, 6, and one from 7, 8, 9. Not necessarily in that order, but they need to always appear like that. And then these are consecutive and these are consecutive. Okay, so as chat has pointed out, this line needs to sum to a multiple of 10, which means the things not on that line, because the whole box sums to 45, the things not on that line need to sum to 5 more than a multiple of 10. But a close examination of the available digits suggests that there's only one option for digits that are 5 more than a multiple of 10 that you can fit into a Sudoku. And so we get to do a 5 dance. Ba-boop, ba-doop. Wah. Ba-doop, ba-doop. Wee. Ba-doop, ba-doop. Wah. Thank you, Zach. And so that means this line sums to 40, which means that it is a total of 4 dominoes that sum to 10. And spoiler, 2 consecutive numbers don't sum to 10. So actually my dominoes get broken up like that. So you have sort of this string going around the around here of things that add to 10. Let's see. None of these are 9. 9 can't go in a circle. Oh, it's because this isn't an arrow. These are averages. The arrow is the average. Sorry, I didn't realize that this was these were average arrows. Sorry. So yeah, so 9 can't go in a circle. I definitely agree with that. So yeah, so 9 goes here because it can't be that the average of this digit and this digit is 9 without them both being 9. So in fact, that's a 9 and that's a 1. You can't even get an average of... Oh, no, you could get an average of 8 with a 7, 9. That would work. Okay. Let's see. Should I just color this? Just... Oh, yes. What digit is consecutive with 1, 2, and 8? There we go. That makes these a 1, 3. So these are 3, 4, 7, 8. No, not 7, 8. 3, 4, 7, 6. So therefore, this needs to be 3, 4, or 6, 7. That one wasn't a 6, so that one's not a 4. Oh, and this one wasn't a 6, so that one's not a 7 either. So we get that sort of arrangement. Oh, and because this one wasn't a 7, it means that one's not a 3, I suppose. Oh, also this is low. Which means that all of these cells are going to be low. If I sort of count around, because that's how entropic lines work. So that's going to be rather huge because now that's a 2-3 pair in this row. So that's not a 3. And if that's not a 3, it means that's not a 7. And if that's not a 3, it means this isn't a 4. And if this isn't a 4, it means that's not a 6. So we've got all of that hanging around. So there we go. Okay, now one of these is averaging 3 and the other is averaging 6. So the average of 3 one definitely doesn't have a 3 on it. And the average of 6 one needs to be a sum of 12. Okay, so the average of 6, if you look at it, needs to be 3, 9, which means one of these definitely is a 3, which means this isn't. So that is a 2 and a 3 and a 1 and a 3 and a 2 and a 3 and a 1 and a 3 and a 2. And so we said that worked out that way. So this works out that way. And we get that. So we have now filled in lots of things that we have. Okay, so we've got a pair here. It's a 7-8 pair. Let's see. These are a 4-6 pair, I am being informed reliably. So one of these is 4-6. Let's see. Okay, so the 4-6, there's a 4-6 over down here somewhere, but who knows where. There is a 9 in one of these two cells for what it is worth by Sudoku. There's a 3 exactly here by Sudoku. That seems more useful. And this is not 4, 6, 3, 7, or 1, 9. So this can only be 2, 8 if you look at this. Because of those and that. And seemingly there's a 2 in this column. Oh, no, there's a 2 in the box. I see. So this is an 8. That's a 2. And now this can now only be 4, 6. And so that is a 4, and that's a 6. Okay, and Laura says this one can only be 4, 6. Let's double check. So it's not 1, 9. It's not 3, 7. Okay, why isn't it... Oh, it doesn't have... Right, neither of these can be 2. Very good eye there. Okay, so this is 4, 6. Okay, yeah, I agree. Although it would have taken me forever to notice that those two 2s looked at the 2 cells on it to realize it couldn't be 2, 8. So one of these 2 cells is a 5 because I need a middling digit on here, and 5 is the only one available. So one of those 2 is a 5. Let's see. Oh, one of these 2 is a 7 for the same reason, because I've used the 8 and 9 and I need a high digit. So one of these 2 is a 7. Let's see. Are there other places I can... there's a 4, 6 pair in this box. So one of these 2 is a 5. For whatever that is worth. So one of these 2 is a 5. Oh, that's really clever. Garion points out this can't be 5 because if this is 5, it means this needs to be middle. But now this is looked at by 4, 5, 6. So that's not the 5. That's the 5 and that's the 9. So we can highlight around and say that those are all 7, 8, 9. And these are all 4, 5, 6. Am I sure row 2, column 3 was a 9? I had 9 corner marked in one of these 2 cells, didn't I? Why did I have 9 corner marked in one of these 2 cells? Is that not what I actually meant? Oh, I had 9 corner marked in one of those 2 cells. Okay, so that's a 5, but I don't know about the rest. So these are 4, 5, 6, and these are still 7, 8, 9. And so we still get things like that is a 7, and that's a 5. That's an 8. That's a 7. That's a 7 and an 8 and a 4. That has become a 5. So we end up with all of that stuff. Oh, that's an 8 now. So that's a 7. It's a 9. See, I told you it was a 9. So that is not a 5. This is a 6. It's not a 5. Not a 5. Okay, we've got a 4, 6 pair here. For whatever that means. 5 is placed in column 4. If you look at it, these two cells just can't be 5. So that one is a 5. And so these two digits are something. They seem to be a 1 and a 4, 6. 1 is placed in row 1. Someone said a while ago, and then we got distracted by other points. But it was true then, and it's true now. I mean, if anything, it's even truer now than it was then. So we've got all of that. And now I think we can mark the whole rest of the grid, because I think now it will probably succumb. 7, 9, 3, 6, 1, 4, 6, 8, 5, 4, 9, 3, 2, 8, 2, 7, 3, 8, 9, 2, and 7. Very nice. I enjoyed that. Let's see. Let me pick out another puzzle. If I'd done this... I have a Naverio puzzle here with a novel rule set. Let's see. So, happily, Ratfinks, this took me way longer than 12 minutes. Yes, sometimes the 2-star is really sort of the point where, like, some of them just sort of, like, go, like, bam, bam, bam when we do them on stream. And then some of them have a little bit of friction. But when there's a lot of eyes looking for it, it can be the case that, like, something like a hidden or something, or Garian's observation about that one cell being 5 can sort of tumble things down quickly. Also, a lot of times when we solve 2-star puzzles, someone makes a 5-star deduction that collapses things earlier than it was intended to have them collapse. All right, let's have a look at this molecule puzzle. I don't know what a molecule is, but I suspect we'll find out. Place the digits 1 through 9 in each row column and outline 3x3 box. We have normal arrow rules, so still circle is the... Well, sorry, I say still. The arrow now is the sum of the things. And molecule cells are either electrons or non-electrons. A cell containing a digit from 1 through 5 is an electron. Each atom, big circle around a corner, contains electrons whose digits sum to 8. Electrons can contain digits bigger than 5. I see. Okay, so all the digits from 1 through 5 are electrons, but there can be other electrons. I assume it means electrons can contain digits greater than 5, because I'm assuming it's saying you can do that, but and make it like... Actually, no, you can't. You could never include a 6 or whatever. Oh, I guess you could if they crossed boxes, maybe. So I think now... I think in this puzzle you can't. The problem with 6 through 9 being sometimes electrons is that you can't then make them sum to 8. Unless you... oh, you could have a 6 and a 2. No, you're right. You could have a 6 and a 2. Yeah, you're right. Okay, so yeah, yeah, okay. In this instance, though, that's not going to work. Okay, so these things are length 3 arrows, so they're 6, 7, 8, 9. This one's also a length 3 arrow, so it is also 6, 7, 8, 9. So we've got that. Now, I know there's a lot of numbers. So all of the numbers along here are at most 6. Because they're on an arrow. And that seems relevant given that 6 is the only number that's not an electron that is on here. So if this is a 9... So the only way any of these... Sorry, let me say this the other way. The only way any of these numbers are 6 is if the sum is 9, and then there's a 1, 2 there. And, well, in this puzzle, not an electron, Tristan. And so... so in phrased a different way, the only way that this can possibly be 9 is that... we have that 1, 2, 6 combo, and the 6 isn't an electron. So there's a way it can be 9, but it's a little tricky. Selena points out, though, that 6 doesn't work very well, because if I make this a 6, then I have a 1, 2, 3 here, and I need 2 more, because those are all electrons, and that doesn't work. And if this is a 7, I've got a 1, 2, 4, and I need 1 more, and that doesn't work either. So actually, these are an 8, 9 pair, and one of them does have a 6. And if one of them does have a 6, then that means it's 1, 2, and 6. And so the 1, 2, and 6, the 6 has to be a non-electron, and I need to have a 5 in one of these cells. In order to make that work in that side, whichever side that happens to be on. And this digit is now only a 6 or a 7. So these are not 5 or 6. They definitely contain a 1 or a 2. Oh, right. The one green has to be... the one green has to be 5. The other green has to be bigger than 5. So actually, these are a 5, 6 pair, making these a 1, 2 pair, and making that digit a 7. So let us bring out Zach for the 7 dance. Thank you, Zach. Thank you. Much appreciated. Okay, so Garion points out that I actually know that the 9 arrow is 1, 2, 6, which means there's actually a 1 on both sides here, which actually places that 1. And then these are a 2, 4 pair. And now that means that the 8 arrow can't be 1, 2, 5. The 8 arrow needs to be 1, 3, 4. So we've got 1, 2, 6 on one side. One side is 1, 2, 6, and one side is 1, 3, 4, when you look at these. Because the reason it can't be 1, 2, 5 is that then I'd rule 2 out of both of these cells, and that would be a big problem. Okay, so these cells are large. This can't possibly be a 1 because of the white dot. Let me just go ahead and note. Or a 3, actually. Oh, there's just never a 5 in any of these arrows because of what I said, because they're either 1, 2, 6 or 1, 3, 4. So I can just knock the 5s out. So this digit is odd. It is a 3 or a 5, I suppose. let's see. Oh, and these aren't 6 because there's a 5-6 pair in the row, I suppose. Let's see. In this column, maybe I don't really want to write what's in the column. There's a lot of digits left in the column. Oh, there's a 7, 8, 9 triple left here, isn't there? Yeah, I think these are a 7, 8, 9. No. No, that's not true. Wait, actually, it is true. Okay. What's really happening is that this is a quint. This is a 1, 2, 3, 4, 6 quint, which means that this is definitely 5. Oh, this digit could be 7. Sorry, but it's not 3. But it could be 7, Todd points out, right? So these are a 5, 7, 8, 9 quadruple because of these being a quint. And so because of that, let's see, the 2 or 4 here. Yeah, one of these is a 6. Okay, I thought something to do there. The fact that these two cells aren't 1 or 2 is interesting, but I can't quite figure out what to do with it. It wasn't a 3, Garion, because these cells are a quintuple of 1, 2, 3, 4, and 6. So this one's not a 2. It's a 4 or a 6. Okay, and so if this is a 4 or a 6, it means that these aren't 4 or 6. So these are either 1, 3, 4, or 1, 2, the other one. Okay, so this is either a 2-cell sum or that digit's a 1. Those are the only 2 options because none of these cells can be 1 is what is happening here. Okay. And if this is 1, 2, then the answer is that this needs to be 3, 5. Hey, Naverio, how are you doing? Yeah, the fact that like a 3-cell sum needs a 1 would make that a 1. Otherwise, this needs to be 3, 5, I think, because I can't do yeah, that's the only 2-cell sum. Sorry, that's not true. I could do like 1, 7 or something like that, or 2, 6 actually would still work just fine. I do know one of these is a 6. I don't think that's super exciting. By any stretch of the imagination. Is this arrangement or that arrangement somehow more interesting than it looks? Oh. Yabervon is pointing out one of these is a 6 because, yeah, the 6 up here is definitely in this row. So there's no 6 there and no 6 there, and that's not a 6. So the only 2 cells that can be 6 are there. So one of these 2 is always a 6. It does feel very relevant, although I don't quite know what to do with it. Let's see. Uh, Yeah, I think coloring the 8 9s is smart, as Garion and Todd are suggesting. This 8 9 goes in one of those two places. This 8 9, it goes in one of those two places. And that means that, oh, it almost but not quite means that these are an 8 9 pair. Actually, no, it doesn't mean that these are an 8 9 pair, because one of these two is purple now, one of these two is blue. Darn it. So sadly, that cell can still be an 8 9. Let's see. Okay. These digits now actually, this is actually very interesting because the 3, 4, 5, 6 is actually very worth noting. Because only one of these digits is allowed to not be an electron. Because of the fact that 7, 8, and 9, only the 6 cannot be an electron. And so one of these does have a 6, together with a 3, 5, or a 3, 4. Sorry. A 6 together with a 5 or a 4. And the other might have 3, 5. If the other has 3, 5, that means these other two need to be too big to count. So they would have to be 6, 7, 8, 9, just based on which side of this has the 6. Okay, but the 6 can't go on the same side as the 3 because of that. Oh, that's right. This is not a 6. Thank you. Because I have some pencil marks looking down at it. The 6 can't go on the same side as the 3 because that would put 4, 5 on the other side. And I definitely can't have 4, 5 on the other side. So we're either going to do 3, 4, 1 or 3, 5 on the side without the 6. So then the side with the 6, again, either has a 6 with a 4 or a 6 with a 5. The 4 only goes with 1, 3. And if it's a 6 with a 5, then there's going to have to be a 3 on the bottom. Because there'll be a 1 on the other side. Boy, this is... I'm not sure if this puzzle is intended to be a lot of, like, look ahead on the, like, bilateral symmetry and sort of try and map out everything. But that's definitely what I'm doing. Because sort of there's two universes, and you can picture what the two sides look like in those instances. J40 says then there's always a 3 on each molecule. I did sort of think that was the case, but I didn't want to go back and check it. But yeah, you can't put the 3 with the 6. So if these are 3, 5, then that's a 6 with a 4. Yeah, okay, yep, so that's true. So yeah, so there's 3s, so there's a 3 down here. Sorry, there's a 3 down there. Yeah, so the way to say this is the electrons in the first row are 3, 4, 5. Those sum to 12. And so I need 4 total more. but I can't do 4 plus 4. Or sorry, I can't do a single 4 as my 4 more, because if I do a single 4 as my 4 more, then the 4 goes with a 4. Right? That doesn't actually sound right. I'm going to look at Jay's point. The total sum of the electrons in the two molecules, you get 12 in row 4. Sorry, no, that's not the point. 2 in row 5. Okay, so Jay Dyer is saying that what I should do is I should realize that I can't possibly put a 2. Yes, that's very clever. So this is also from the fact that these things, the molecules here sum to 12. So I need 4 more. And so I can't then use a 2 because there's nothing I can add to 2 that will Sudoku logically get me to 16. So I need to place a 2 in this row somewhere. I can't put it in the box with a 2. I can't put it there. So in fact, this has to be a 2, 1, 1 arrow, which makes that a 1, which makes that a 1. So no 1 over there, no 1 there. So we've got that. Let's see. So yeah, so 1 in box 4 is placed here. Which means these either have a 6 or are 3, 4. Either way, this digit needs to be big, because this needs to be a 7, 8, 9. Because there's no way I can also add this to the count. It's because definitionally, the only thing is all numbers from 1 through 5 are electrons. I agree these rules are worded terribly, and I also agree with Selena. I think the rules are bad, which is two sort of separate issues, but I think it's true. Oh, it could be a 3 if the top is 4, 6. You're completely right. You're completely right. Let's see. Oh, I'm not blaming Univaria. This is a speed setting thing. I'm not. I'm definitely not blaming you for the fact that the rules are bad. Right. 5 can't go on this side, is Selena's point, because then I'll have 1 plus 5. I'll need 2 more. Also, let me do an example for ELSF. This would be a valid fill of an electron, because I could just declare that this 7 is an electron, even though it doesn't have to be. So you get to option for each 6, 7, 8, and 9 in the grid. You get to decide whether it is an electron or not. Okay, but yeah, definitely true, ELSF. There is a 5, so there can't be a 5 up here, because then I would need to get 2 more, and I can't get 2 more because there's no cell in here can be 2. So there's no 5 over here, which means there is a 5 over here, which means there's definitely not a 4 over here, which means there is a 4 over here. Oh yeah, maybe I should remove that 7 and 8. That's probably a good idea. Okay, so one of these is a 4. And yeah, I know one of these things is going to be a 3 for sure, based on that. Let's see. I know there's going to be a 1 in one of these two cells. It's interesting that there's no 1 on this. So this only has 2 electrons on it, I guess, is the conclusion here. I don't quite know what to do with that, but sure. Let's see. Okay, this digit is at most 7 because we have an 8-9 pair on the column, but also these two are at least 2, 3. So that means that this is 5, 6, or 7 are the only actual options. Oh, it could be only 1 electron. That's true. I could have just 1 electron. Just declare 8 to be an electron and make that a 6, 7, 8, 9 quadruple. That does seem like an option. Let's see. I do know one of these cells is a 2. Sure. Yes, same story here, actually, Garion points out. This is also from 5, 6, 7, because, again, we've got the 8, 9 looking down, and neither of these can be 1. Now, here, I bet we can rule some things out. So 6, for example, definitely doesn't work, because if this is a 6, then these 3 are all electrons that sum to 7, and I need another 1. 7, I fear, would work. And 5... Oh, 5 doesn't work for a hilarious reason, which is that if this is a 5, these sum to 5, so these sum to 6, and so that's a 2, except that would break both ways to make 2. So, in fact... or sorry, both ways to make 5, right? If this is a 5, that needs to be a 2 to complete my electron, but that's not possible. I suppose also you could say it as if this is a 5, then I'm actually insisting that these 4 cells sum to 8, and that's not going to work in any way, shape, or form. There needs to be a number in here that's not counted. Yeah, I eventually, I think, stumbled upon the reasonable way. So that makes this an 8 or a 9 for sure, because these already sum to 8. Oh, sorry, could be 6. Sorry, 6 as well. I mean, I think the rules just need to be some subset of these digits sum to 8. Period. And just delete the whole 1 through 5 implication-y weird part. Like, I don't think there's anything wrong with saying some subset of these numbers sum to 8. I think that would be a perfectly fine rule that would then be easy to explain and would not have the weirdo-ness going on here. So these are 2, 5, or 3, 4, because they're not 1, 6. I guess I might as well write that down. Oh, so these are an 8, 9 pair. No, not quite. Sorry, these are not an 8, 9 pair. Sorry. But 8 and 9 are in these 3 cells, is I guess what I know. Well, this one's certainly not a 9. And if this one's an 8, then it makes that one a 9, which makes this a 6. I'm trying to think. I think that means there's something that this can't be, but I'm not sure. Let's see. 7 in box 3, says Garion. Yes, 7 in box 3 is up here. So that makes these definitely from 7, 8, 9. And now that means the 7 over here is now down here. And that rules 7 off of that cell. Which means these are either 2, 3 or 2, 4. Because now both of these things are things. Also 7, 8, 9, right? These so that's not 5. Because there's an 8, 9 there, because it's a 7 purple pair, right? Not more Sudoku. One of the... Oh, no, sorry, that's not true. That could be 7. I think Naverio wants me to declare that this cell is a naked single. I think. But I'm not 100% sure. Let's see. Oh, it's the 2. Yeah, so the 2 in this box is definitely vertical. So that cell's not a 2. So that cell's not a 5. And 2 is on the arrow, which means this isn't an 8, it's a 9, and that's an 8. So that is a 2, and that's a 6. So that's a 5, and that's a 6. That's a 4, and that's a 3. That is a 3, 4, 2. 4 is only next to 5. That becomes an 8. That becomes a 6 and a 5. That becomes a 4. This becomes a 6, 7, 9. To make sure that it doesn't count. Or 8. No 8 up there. No 5 down here. So this has become a 3, 4 now for real. That is not a 6. This is a 2 now, somewhat amusingly, because if it's not a 2, it's at least 5, and 5 is too big for this arrow because the 1 isn't here. So that's definitely a 2, which means this is a 3 or a 4, which gives us an absurd 3, 4 pair in this row. So we have that for our entertainment. So this molecule does not have 1 on it. So this is just a pair that sums to 8, because a triple would have to have a 1. And the pair is not 1, 7, and it's not 3, 5. So the pair is 2, 6. And note the 6 can't go there. So there's definitely a 6 in this column. And there's a 2 somewhere floating around here. The 2 is probably not in the circle. Or just an 8. It could just be an 8. That's true. You're right. Yeah, I forgot about that. It could just be an 8. Oh, yes, but the 2 in this box is being pointed out by DWeb, is joining this 8, 9 to make a triple. And so, in fact, that's an 8, 9 pair now, which has made that a 2. Would seem. So the 2 actually is here with a 6. And we know the 6 isn't there, so that's not a 6 anymore. And that actually places the 6 into this box, which makes that a 6, a 4, a 3, 4. Over there. The 2, again, still isn't in the arrow. And everything that's not a 2 or a 6 has to be from 7, 8, 9. Just for the record. So this is not a 9, at the very least. These are a 1-3 pair, just by Sudoku, it's being pointed out. Because you ask where 1 and 3 go in this box, and just by Sudoku, they go there. And so that makes this a naked single, D-Web points out, which is a 5, actually. And so these are a pair of something and something. They aren't 7 and 9, so these are a 2-8 pair. So we've got these are a pair where that is a 3 and a 4. These are a pair as well of 5 and 6. I know one of these two is a 3, and it's that one. That's a 7, 8, 9, because I can't let this overflow. That's a naked single something. It's a naked single 4, because there's a 7, 8, 9 triple in the column. This is the other 7, 8. Okay. Sure. 3, 6, 9 is a possibility. Yeah, I guess there's numerous possibilities here. What's this pair? 5, 7, 9. Sure. Is it this cell? Is this like a naked single? No. It is a 5, 8, or 9. It's not super helpful. I mean, I guess I can force this cell, right? It can't be a 3, funnily enough, which seems like a very Navario thing to notice, because if this was a 3, that would be a 1, and it would break that cell. Can't be a 4, because it sees a 4. It can be a 5. It can't be a 6, because it would make that a 4. Can't be a 7, because there's 1 in the column. Can be an 8. Or a 9, and those run through the options of this being a 3, a 6, or a 7. Let's see. So we've got that. Man, I almost have a 5, 6 virtual pair here, but not quite, because there's the annoying 9, 7 possibility. Let's see. But so close to there being a virtual 5, 6 pair. There's definitely a 7 on here for what it's worth. So there's a 2, 6, and a 7 in here just by magic. And so there's 1, 8, 9 down here. Oh, the 5 I know is down here. Maybe that's worth noting. Because it can't go on there. Yes, 2 can't go on the arrow is a good thing to notice. Because 2 plus none of these numbers sort of end up working. Let's see. So that sort of crams 5 into one of these 3 cells. Regrettably not too exciting, I'm afraid. Let's see. Is there some combination here that doesn't work? It seems very possible that there's a combination that doesn't work. Oh, row 4 I could finish. That would be a great step. Because I finished everything from these arrows except that. That seems like a very wise thing to look at. So now 1 is just down here. In fact, 1 is placed. And so that sorts out the 3 and the 1. And now actually that makes that a 6 and a 9. Makes that a 5 and a 6. And so now this can't be 5 anymore by Sudoku, and it can't be 8 anymore because that would make this a 6, which can't be by Sudoku. So that's actually 9, 7. It's actually the one I didn't want it to be. 7 and 8. Yes, Matt Laffey, great spot that we had not finished filling in the arrows, which is always my weakness when it comes to arrow puzzles. I mean, one of the many weaknesses I have when it comes to arrow puzzles. This has become a naked 2, funnily enough. Let's see, that is not a 9. This has become an 8 and a 2. So this has become a 7-8 only. Okay, so I think now we can just go full mark the rest of the grid. Let's see, 8, 7, 5, 8, 3, 2, 7, 5, 8, 5, 7, 6, 4, 8, 5, 4. Zeta reads the phone book. 6, 3, 6, and 9. What a weird rule set. I feel like the rule set is like a small tweak away from being there. Now, because I also have it in the bucket while we're thinking about molecule puzzles, because I don't think we're going to do molecule puzzles in the future. Let's do this one now. So this is the other molecule puzzle. I assume stemming from the same thing. Now, this wording of the rules is actually quite nice. Cells containing digits 1 through 5 are always electrons. Cells containing the digits from 6 to 9 may also be electrons, but are not required to be. Are the circles allowed to overlap? And if the circles overlap, does that obligate that that you make the same choice about whether things are electrons or not between both versions of it? The fact that these rules are weird is not Navario's fault. This was a speed setting competition in which the setters were given the rules to use. But yeah, this wording is cleaner. In the intended rule set, a cell is the same identity for all atoms. Notable. Okay, so this we know is 6, 7, 8, or 9. Oh, this is also 6, 7, 8, or 9. And this is also 6, 7, 8, or 9. So this, therefore, could only be a 1 or a 2. Definitely now agree with this statement. And so there's definitely a 6 or a 7 in here. Oh, it could be also a 6, 7, 8, 9 if it's a single 8. Dagnammit with the single 8s. The single 8s get me every time. Yeah, the single 8 option looks very plausible. Unfortunately. This is certainly also 6, 7, 8, 9, though. And this are also certainly 6, 7, 8, 9. Yeah, this digit just can't be 1 or 2 because if this is 1 or 2, Garion points out, actually, it makes every arrow a minimum of 8, but I can't have 3 8s in one of these because this cell sees the entirety of all the arrows. That's really clever. So actually, this is 6, 7, 8, 9. So these are a 1, 2, 3, 4, 5 quintuple for these purposes. So this stuff in both cases counts as being electrony. Oh, this is also a 6, 7, 8, 9. And we know for sure this isn't electrony for what it's worth, because these already sum to a minimum of 3. Let's see. this is certainly a minimum of 6. So this is also 6, 7, 8, 9. Because it could be 1, 2, 1, 2, perhaps. It's possible I could break that combination, that exact combination. Yeah, I think that exact combination doesn't really work. Because if this was 6, it would be 1, 2, 1, 2, but the molecule doesn't work. Because you've used the 1 and the 2 now, and the other 1, 2, so you've got a sum of at least 4, and you're never getting there. But you have to use the 2 now. So you can't not use a 2, because all the digits 1 through 5 you have to use. Because weirdnesses. I do know these cells sum to at most 6, and these cells sum to at most 6. So I actually do know all of these cells are actually counted by their respective molecule. Because these sum to at least 3, so these sum to at most 6. So we can sort of say, okay, all of that is molecularized. Okay. Okay, so therefore this can't be 7, because if this is a 7, yeah, so the 3 yellow digits sum to 8 is the point. Yeah, I was going to start the other direction, but it's actually much easier to do it D-Web's way. These 3 therefore sum to 8, because I certainly am not using that. And so therefore that's a 1 and that's a 9. That's not a 9, so there is a 1 over here. And in fact, all of these are molecularized. And so therefore they need to sum to 8 as well. So this is demolecularized. And assuredly, this is demolecularized because I know there's definitely a digit in here that's from 1, 2, 3, or 4, or 5. So that's not going to count. Oh no, the dance. That's right. The 1 was the first. It felt like we'd done so much in this puzzle, but you're right. We had not gotten a digit. So let us do our digit dance. Boop, boop, ba-doop. Woo! Ba-doop, ba-doop. Wah! Ba-doop, ba-doop. Wee! Ba-doop, 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 wah-ha! Thank you, Zach. Thank you. And so, yeah, so this is another 8, because again, the only way I could make these not all things, the only way I could make them not all yellow is to make them 1, 2, 6, but then 1 and 2 would have to add to 8, and they don't. So, in fact, these are all atoms or whatever, electrons, and therefore that is an 8. And again, there is a 1 over here. Oh, and it's not there. So there's a 1 up here somewhere, probably worth recalling. These are at least 2, 3. So this is 5, 6, 7. There we go. Let's see, 1, 2, 5. Oh, but the sum of these I'm supposed to do, right? The minimum sum of all of these cells together is 15. So, so this can't be a 5 or a 6, so it has to be the 7. And that means these are 1, 2, 3, 4, 5, which makes that a naked 6, funnily enough. And I know these aren't 1. So these are 2, 5, or 3, 4. Let's see. Okay, and this little circle doesn't have a 1 on it. So I need to count at most 2 cells on this need to be atoms. In fact, actually, it's exactly 2 cells because there's 8s looking at it. In fact, the 8 is also up here. The 1, 8, 9 combination seems fairly likely, but not guaranteed. I see people in my chat doing math, which scares me always. It if this isn't a 9, that's going to be a bit tricky. Okay, so these two sum to a minimum of 4, 5, and so therefore this can't be a 5 anymore, at least. This is from 1, 2, 3, 4. So it could be 4, 2, 2, 1, 5, 2. I mean, I do think if your goal is to like create an interesting setting challenge, then it can be a good idea to pick something kind of mind warpy that is not necessarily of the highest quality as rules go. It sort of forces interesting things. I'm sort of looking at these together, which is kind of interesting. If there's no 1 here, then this has to be a 9. But if there is a 1, I feel like this could get away with being fairly small. Selena was talking about adding a bunch of things together, but then Navarro was saying this was meant to be like an easy puzzle, which doesn't sound like I'm supposed to add a bunch of things together. That was why I was not immediately looking at it. These are also from 1, 2, 3, 4, 5, 6. By the way, so if there's no 6 here, then these become a 6, 7, 8, 9 triple. Oh, interesting. Okay, so Garion and Selena, I think, want me to do the math here on these cells. So if I minimize this, it's 15 plus, and so here actually these two are because of the fact that these again sum to at least 15. These two sum to at least 6, because this is at most 9. So if these are at least 6, that certainly at least takes the 4 or 5 off of there as an option. And likewise, actually, we don't have the same thing over here because there's not a length 3 arrow in this cell. But 6 plus 15 plus 3. So the absolute sort of like the so the maximum that these can be is 6 plus 15 plus 3. No, the maximum these can be isn't 6. The maximum these can be is, oh Lord. Oh, the minimum. Sorry, the minimum that they can add to is, okay, is, yeah, right. Is 15 plus 1, 2 is 18 plus, and we said the minimum these can add to is 6. So 6 plus 3 plus 15 is 24, which means these do have to be 7, 8, and 9. So that is 6, and that does actually sort of force that these need to be 1, 2. These need to sum to, in fact, 6, which means this needs to sum to 9 because of the 15 business. So that is a 9. And these sum to 6, so that's a 3. So we have no 3s here, no 1, 2 there. So these sum to 6, and so they're either 2, 4, or 1, 5. But these all sum to 15, so there's no 6 in them. So these are 6, 7, 8, 9. Just because that's a 1, 2, 3, 4, 5 quintuple. So in particular, this is not a 1. Let's see. Those aren't 9. This isn't 7 or 8. This isn't 6 or 8. One of those is 9. So if that's 6, 7, or 8, that means this digit's at least 7. So therefore, it's definitely a 9, which makes that a 6. Coming over here, that's a 7, 8 pair. That makes that a 9. So this is a 1 or a 2. In order to make that work. It feels like 8, 1 is going to be the most likely. Okay, so there's already... Oh, sorry, no. There's being an 8 doesn't mean anything. Sorry. Let's see. Okay, so here... Right, there's no single 8 going on. So there's no single 8 on here, so it has to be a 2-digit sum, which could well be 2, 6. And if it's not 2, 6, then it has to be 3, 5. So there's either a 2 or a 3 here, but unfortunately the 3, 5 seems plausible. Let's see. And I do know that these are a 1, 5 or a 2, 4, so that's worth recording. It's not a 1, so that's not a 5. And so these are 6, 7, 8. I do actually know that because of that. So that's actually useful because it gives me a 6, 7, 8 triple, looking at this and making that a 9. Oh, this circle actually sees 6, 7, 8, 9. So these two are actually definitely atomized. There we go. That is chat points that out right. So the yeah. So therefore they need to be 5 and 3, making that 1 and 8, making that a 7 and an 8, making that a 6. See, that's not a 2 and that's not a 2, so that makes that a 1 and a 5. That makes those not a 5, that not a 3, that not a 1 and a 5. These are a pair of some sort. They are a 4 and a 7. So this one worked out. I don't remember if I ever thought about this one. Did I? It worked out as 1, 7 is what ended up happening, but I don't think I ever thought about it. Okay, and these aren't 2, 3. Okay, so if this is 4, 5 and it's on an arrow, then this needs to be the 1, because you can't have a second 4, 5 on an 8 arrow, or your arrow sums to too many. So there we go. So no 1 there. Okay, this is not a 6, so it's definitely counted because it is a 1, 2, 3, 4, 5. And actually, this is 2, because the only way this could not be is if it was, again, 1, 2, 6, and it can't be because there's a 1, 2 above, so that is also... This needs to be at least a 7, so it's a 7 or a 9, just for the record. Okay, let's see. Row 3, column 2, people want me to look at. Let's see. Not quite sure I see why people are so confident about this one. Oh, it's because of the atom that it's on. Right. It's because of the atom. There we go. Okay, I just that atom just vanished for me. But yeah, this needs to be a 4 because of that, which makes that a 2, which makes that a 5, which means this is the one that's 8. That's the one that's 7. So we get rid of our 4, 5. We get rid of our 2. Oh, this is definitely going to count, by the way. So these are going to need to be a 1-2 pair because this is not 1 or a 2. So this is a 6 or an 8, it looks like to me. It can't count or we have a problem. Let's see. Row 7, column 3 can't be an electron, right? Because that's definitely an electron. Let's see. Oh, row 7, column 4. It's not an electron. It would need to be a 6. Why can't this be a 6? Okay. Well, this arrow definitely has a 4, 5 on it, and so that 4, 5 goes there because the 4 and the 5 in there are gone. That makes this a naked single something. We'll figure out together. 7. This cell is a naked single 7. And so, yeah, these are from 1, 2, 3. Let's see. Oh, yeah, I can color this and color that. And color these. And color those. Just so that people can be confident that we are doing this correctly. Let's see. Making you calmer with consistent coloring. I do my best. This cell is not 1, 2, 3, or 4. So this cell is at least 5. And it seems not to be a 7 or a 9 for what it's worth. Okay. The 8 in this column is definitely up here for what it's worth. Seems very little, but I'm going to go ahead and write it anyway. There's a 7 on the atom in box 6 by Sudoku. There is a 7. I agree. If that were the 7, I would need this to be a 2 and that to be a 9, but that checks out. The box 5 arrow has a 3 because there's only 2 available ways to make this total, which are 2, 3, 4, and 1, 3, 5, because 1, 2, 6 is broken. There's definitely a 3, and that is true. And so we're either 2, 3, 4 or 1, 3, 5. Those are my 2 options. Let's see. Yeah, it is a little... The way that it's called molecules, except the things are atoms and electrons, is a little bit strange. I will 100% grant that. Let's see. The only way this isn't an electron is if it's 6, 3 exactly, for what it is worth. Yes, there's also a 6 here. And the 6 is definitely not doing electron things. So we don't have enough room for a 3-cell electron. or sorry, for a 3-cell whatever. We don't have room for a 3-cell sum anymore, because if there were a 3-cell sum, neither the 6 nor the 7 would count. So the other thing here needs to be an 8 or a 9. So these are always from 6, 7, 8, 9, and those aren't 9, and that one's not 8. So we've got that at least, which does then mean this digit's big. This is in fact, that can't even be an 8 actually, because this is a minimum of 2. That means this is an 8 or a 9. This can only possibly be a 2 or a 3. Let's see. It's too hot to think that precisely. That makes sense. Yeah, one of these choose a 1 just by Sudoku. These numbers aren't from 6, 7, 8, 9. So just by Sudoku, these are 2, 3, 4, 5. Which is interesting enough. So that's the last 1, 2, 3, 4, 5 in the box. So this is also a 6, 7, 8, 9, and it's not a 6 or a 7, actually. Oh, we actually have a 6, 7 pair that I did not notice. So these are an 8, 9. So that one's not counted, for what it's worth. I was going to say we know this isn't 1, 3, 5, but we don't. But we do know that these are a 6, 7 pair for this row, right? Because this row needs a 6 and a 7, and it's not there. And so this is the other 3, 4. So we've got that. Mentally trying to decide if I thought one of these options, like if the 8 broke, because the 8 would force to 6. 9 there. The 8 forces a lot, but none of it I think interacts that I can see. If it does, I am missing it. See, these cells can't be that many things if I just write them in. Don't listen to Sven. They can't be all those things. They can't be 6. They can't be 7. These can't be 3. That one certainly can't be 8. Let's see. Yeah, okay. Sure. See, where's the 9 in this column? The 9 in this column is definitely in this box. I guess I knew that already. Kind of. Oops, I wrote 6 instead, but it's a 9. Oh, only one location for 8 in box 5. That's true. Very good. One of those is an 8, or that cell's an 8. Good. Let's see. If this is a 9, this would have to be 3, 7, or 4, 6. And if this is a 7, it's going to have to be 3, 4. That doesn't quite get me anywhere, does it? Oh, and it's definitely not an electron. I agree. So I need at least one of these to be an electron. Oh, they can't both be electrons. Because if they're both electrons, the sum would be too big. So one of these exactly is an electron. And the one that's an electron can only be a 5. Right. Okay, that's huge. Okay, this 8 actually did something really cool because I need an electron and it needs to be a 5, which means this needs to be a 3 in order to make that work. That therefore is a 2. That therefore has become a 1. That might be the observation that gets us there. Let's see where the chips fall once we are done with all of this stuff. Okay, so that has become a 2. Let's see. That has become not a 2. Oh, it could have been a 6, couldn't it? Dagnammit. Right. It doesn't have to be 1, 2, 3, 4, 5. It could be a 6. In any event, it's a 5 or a 6, so this certainly is a 2 or a 3. I'm willing to go that far. That does give me a 2-3 pair still, which does make this a 4 and a 3, and makes that a 5. Makes that a 4, which makes this a 2 or a 3. 2 3s make that a 1, and then 2 3s look up and make that a 1 and that a 2. Good catch, Selena. This is not the stickiest rule set of all time in terms of mental ability to remember what it is. Okay. These are somethings. This is not a 2 or a 3. This is a 5 or a 6. Oh, this 7 is no longer able to be counted. So these two need to add to 8. So this definitely gets counted regardless of what happens. Let's see here. Yeah, whichever of these is a 7 gets counted. That one's not a 7 anymore. Or a 6 for that matter. I don't really need the 6, 7 corner marks anymore. Let's see. There's no 1 on this, but it could still be a 3-cell sum. Oh, no. No, yeah, it could be 2, 3, 3. That would be fine. Let's see. Yeah, I know exactly one of these is a 5 or a 6 and counts towards my my electroning. Yeah, one of these two has to be a 2. These two need to add to 7 for what it's worth. So actually, this one can't be a 2 because this one can't be a 5. It doesn't seem super beautiful. Okay, Garion was saying the point I just said, and then Garion also says that if this is a 5, it does something weird. Makes that a 5 and that a 2. Which makes both of these 3s. I think. Because if this is a 5 and a 2, then that's certainly a 3. And that's certainly a 3. So yeah, this can't actually be 5. I suspect that's not the intended step. Let me look at what Selena said, and if it does it, I'll do it. Otherwise, I'll do Garion's step. If row 3, column 4 is 8, then the column sum to 8, but also the atom sum to 8, and it repeats. It's the weird deduction. Yes, it is exactly that. Got it. Okay, yes. So in the world where this cell is an 8, what happens is we force these two cells to add to 8. However, these two cells add to 8, and these two cells are the other way to add to 8, but that makes these two the same digit, which is the... that's a deduction I use a lot in my puzzles. So because of the fact that this column has left an 8 and the 2 ways to add to 8, the other way to add to 8 can't be that one. In fact, I think that actually, yeah, so this definitely isn't the 8. So that is the 8. Yeah, if this was a 2, we were going to have a similar sort of string of stuff. So we said that can't be the 8, and so therefore that is the 8. And so this maybe counts and maybe doesn't, I think, or maybe I actually know whether it counts or not. I know one of these two is an 8. Right. Uh, right. It's not possible. So what I was thinking is, oh, it could be a 2, or sorry, this could be a 3, that could be a 6, and that could be a 5. But 3, 6 breaks this domino. So I can't do that. So this counts and this doesn't. And so this is a 6, 7, or 9. No, it's not a 9. This is only a 6 or a 7. In order to not count. That gets me a 6, 7 pair in column 5. Oh, let me first do Garian's point that I know this is a 2 because I have a molecule here. That seems like a good idea. And this 6, 7 pair looks down at that cell and says this isn't a 6. And this cell is assuredly a 3, 4, or 5. And it's, oh, yeah, it could be a 5. Let's see. What is the rest of this row? 3, 4, 7, 9. Okay, I don't get a whole lot out of that. Yes. So now this is a quadruple that doesn't include 6. So now this is a 6, is Matt Laffey's point, which is good because it makes that a 2. Is that a 3 and that a 5? Makes that not a 5. Makes that a 2. Okay, so if this is a 7, this will be the other 3, 4. And if this is a 9, this will be a 6. Because it won't be able to be 4 or 5. So this is either a 3, 4, or a 6 for what it is worth. Oh, we have 8 1s. So that is the last of the 1s, it would seem. Interesting if true. Let's see. Yeah, I know one of those two is a 2. This is a 7, 9, 6. Yeah, I was trying to look for combinations that didn't work because it seemed like maybe there was going to be a combination here that didn't work. Let's see. We can mark this. So one of these two definitely counts. Because the only thing they can be that doesn't count is 6. And they can't both count, actually. That doesn't work either, because if they both count, then the sum is too big, right? Oh, maybe they could be 3, 5. Sorry, I think they could be 3, 5 and both count. That would make these 7, 9. Let's see, I don't think I know a lot about that. Yeah, I do not know a lot about that. That's true. There's a 2 in row 3, which goes here, I am told. So the 7 in row 3 is now over here, so that means that cell's not a 7 for what it's worth. It means one of these two is 7. Let's see. This digit is big. It is an 8 or an... it's an 8 or a 9. So that gives me an 8-9 pair. So that now makes that a 7 and a 6. A 6 and a 7. So makes that not a 6. Means these aren't 3 or 4. That 3-4 pairs made that a 9. So the 9 definitely doesn't count. Okay, so this definitely does count, though. So we have that going on. We could do 4-4 with a 6, I think. Still. ELSF. So one of these two counts, but I don't think I know which one yet. Let's see. 3, 4, 5. Yeah, I know one of those two is a 5. It doesn't really tell me anything. One of those two is a 2, but it doesn't really tell me anything. Okay, we did have before Garian's point about this not being able to be 5 that we can go back to if we need to. I was hoping we were going to skate around that, but maybe we still come back to the same place. Yeah, we've got our 8-9 pair here in this column, our 8-9 pair here in this column. Yeah, that is it's a little unfortunate, but I think we might have to use it. So so just to remind you, this can't be 5 because of what it does with these two arrows. Namely, it can't be 5 because it makes that a 4, which makes that a 3. But when this is a 5, it also makes that a 2, which makes that a 3. So this can't be a 5. Oh, okay. So Selena has the more elegant way that you're supposed to see this, which is that these are two different ways to sum to 7. So that is one way to sum to 7, and that is the other way to sum to 7. And so therefore, these two digits are the same. And so therefore this sums to 7 as, sorry, this sums to 7 was supposed to be green. So therefore these two sum to 7 as well. And these two, yeah, we know these two sum to 7, so they're green. These two are orange. This presumably eventually gets us somewhere, right? Let's see. If I continue with my coloring, will it eventually get me to the place that I want to go? Let's see. 6, column 7. Yes. So where is this? There we go. Yep. So exactly. So this is there. That's the point. And so these two have to be the same by coloring. And so the only same thing they can be is 3. Okay. That feels like an intended step. And so that is a 4. That is a 2 and a 5. It's a 2 and a 5. That is a 3 and a 4. So that is a 3 and a 4. That is a 4 and a 5. That is a 6 and a 5, and that's a 7. So we now know that is counted and that is not. That is a 6, so it's not counted because we know the counted thing is a 7. So that's a 6. That's a 9 now because of math. And that is a 4 and a 3. Oh boy, that was tough. I did not find that as easy as Neverio led me to believe I would find that, but there was a lot of cool sort of stuff in there. I'm always impressed by people who speed set these sorts of things. Although I realized the last puzzle we set on stream, we weren't infinitely far off from doing a speed set. It was more than an hour, but it wasn't our usual like 3 hours or 18 hours or whatever that we quite often get on puzzles. Yeah, I still feel like the molecule constraint should count exactly the numbers from 1 through 5, or count any numbers any of the time. The always counts these and sometimes counts these feels like it's one too many rules for the rule to have. I think it makes it so that like it makes it so you can't ever make any cool deductions with it, which is a little unfortunate. But I think it's playing very near a very interesting space. That is my instinct from the puzzles of it we have done. Anyway, I'm going to take a quick break and then come back and do some 6x6s. We'll see exactly what I pull up, but I'll be back in a moment. All right, welcome back. We haven't done some 6x6s in a while, so we're going to wrap up stream with some 6x6s. I at some point will get Tristan has offered to write a program that will pick out the 6x6s we haven't done so that I can go back and find them, because there's currently a lot of scrolling, but we've not done that yet. So at some point we will do that. So this is a double arrow irregular. So the sum of the circles is equal to the sum of the digits along the line. So for example, I could do 1 2 1 2 and then 1 5, and so these sum to 6 and these also sum to 6. Note they're not between lines, despite having similar appearances. So let's see. Trying to figure out the there's some arrangement that doesn't work with double arrows because it would end up repeating a digit, but I don't know if we actually have that arrangement here. Let's see. Let's see. Garion says we can't repeat digits in here. It would cause some sort of irregular problem. Because if that's true, that would be really helpful. Right. If there's a repeated digit here, there we go. That's cool. Yeah, if there's a repeated digit in these cells, say there's a 2 in both of them. Now the 2 in both of these regions has to go in row 1, and that doesn't work. So that actually means these sum to a minimum of 10 and a maximum of 11. So they're from 1, 2, 3, 4, 5, and these are from 4, 5, 6. And one of these is definitely a 6. And in these, we definitely have a 1, 2, and 3. For what it is worth, because of the fact that these are all distinctive. So the point is I have a little extra region here. Because if I just highlight the first 3 rows and knock out the 2 triangular regions, we get that. So one of these 2 is actually a 6. Because we know we didn't put a 6 there. So we've got that. For whatever it is worth. So we need 2 6s in columns 3 and 4. And so they're going to go in these cells. So the 6 for this region is in those cells, and the 6 for this region is in these cells. For what it is worth. So the 6 in this row is in one of these 2 cells. Because this row still needs a 6 and doesn't have one yet, and that's the only place we can go because we know one of those 2 is a 6, so that can't be a 6. And now that is almost, but not quite all of the 6s. Oh, right. My last 6 goes in one of these 2 cells, right? Yeah, one of these is a 6. Okay, I know that. Right. Because this is a length 1 double arrow, this can't be a 6 because this number's bigger. So I at least have that. So it's really one of those 2. Right. The purple's the other digit in purple is 4, 5. Garion points out. So we actually really have 4, 5, and 6 here. Garion points out it's not the same 4, 5 that is in green. Right, because if green is 4, 6, then it's in here. Right, because 1, 2, 3 adds to 6. So the other digit sort of repeats in yellow, is the way to think about it. Let's see. Yeah. So one of these at least is small, because one of these sees both 4 5s. And 6, of course. So one of these two cells is definitely a 1, 2, 3, at least. Could be both, of course. Yeah. Okay, yeah. So if this cell is a 6, then that cell's, of course, not a 6, and that cell's not a 6. So then this cell's a 6, and that makes that cell a 6 because of this 1, 2, 3, and I can't have both of these be 6. So this cell is emphatically not 6. So the 6 in this, so this is not a 6 for what it is worth. So 1, 2, 3, 4, 5. Yeah, these are definitely a pseudo region, right? Because this is just these two regions minus that region. And so this region has a 6, but that 6 is definitely in row 4. So therefore, that is never a 6, is AFK's point. So the 6 that is in this row is definitely in one of these two cells. And now we've actually sort of fully broken up all of our 6s. So yeah, we've got if that's 6, that's 6. Yeah, that okay. Okay, so this isn't even 6, actually. So these are actually at most 4 now, for what it's worth. Not very much, I suspect, but who knows. This digit I know does not repeat there, for what it's worth. That's the trick that I was thinking about before. So this digit, if I ask where it goes in this region, this digit definitely goes in one of those two cells. Which is kind of interesting. Very kind of. Like 5, 5 seems like it would take all the air out of this. So, like, it does tell me this can't be 1 or 2, at least. Because if this was 1 or 2, then it would assuredly have to go... okay. 2 doesn't work. Can't be 1, because if this is 1, I could not put the 1 on top of the 6, because it would put a 6 on the line. And I can't put the 1 in the circle. Annoyingly, I think actually 2, 2, 1, 3, I think actually works. Oh, could this have been 1? Was I wrong? Sorry. Maybe actually, oops. Maybe actually this being 1 does actually work. If that's 1, then we certainly can put the 1 there. So I have to put the 1 there. That's a 6. No, the 1 doesn't work because it would still be 6 and 6, right? The 2 circles in row 4 are the same as the 2 circles in row 5. That's true. Just because of this being a region and this being a region, these 2 circles are the same as those 2. But I agree that that is interesting. Like I feel like these 2 being the same is the more interesting outcome, but I have not seen what to do with it yet. AFK thinks that they have seen it. AFK has retracted. If none of the yellow digits are 5, then these 2 aren't 5 either. And so then I'm obligated to put the 2 5s there. I don't know how interesting that is, but I notice it. If yellow doesn't have a 5 in it, then that happens. And if yellow doesn't have a 4 in it, the same thing happens. If yellow doesn't have a 4 in it, then these 2 do. And so, sorry, then these 2 do, and so those can be a 4. So these are at least from 4, 5, 6. I can at least say that. Because whatever digit of 4 and 5 it is that does show up, or sorry, that doesn't show up in yellow, doesn't show up there either. Garion says this can't be a 4, although Garion is referencing a pseudo region. I think it's just literally the region. If this is a 4, that's a 1, and then I don't think this region has a 1 in it. Right? This cell, where does it go in this region? So anyway, so this can't be a 4. And I think, sorry, I think Selena's right. I think I said that backwards. I think I did unfortunately reverse it, sadly. Because it's the yellow 4-5 and the green 4-5 are the same. Sadly. Dagnammit. So the fact where this digit goes in this region does feel interesting, because this is either a 4 or it's equal to the other circle, which means that this is either a 5, in which case that would be the 4-1 option, or they're equal, in which case this is at least even. So this is 2, 4, or 5 only. Yeah, the tiniest of tiny deductions. Yeah, it's never 3. I guess that's really what we did. Oh yeah, and they can't be 3, 3 either. Right. Okay, sorry. Can't be 3, 3 either because of the basically, if this was 3, that was going to be 3, and then this was going to be a 6, except we know that's not a 6. No, because if this is a 1 or a 2, it's the same as that, and if this is a 4, this has to be a 1, because it's the only thing that would make this sum to a number that is a Sudoku digit that is less than 6. Right? I think that's true. If these two are the same digit, that digit goes there in column 2, which would make it go there in yellow, which would make it go there in row 1, which would make it go there in this this thing, which is a little suspiciously worrying. Maybe I'm supposed to say exactly the same words over here, or very similar words over here, because this is either the 4, 5, 6, or it's equal to this. Does it, Garion? Because the 5 would go there otherwise. Yeah, this peeking in. Oh, right. This is equal to one of these two. And so that's the thing. These two circles are these two circles. So if these two are the same, then these two are the same. If these two are different, then that's a 4 and a 1, and so then that's also a 1. Oh, well, that just doesn't work. If this is a 4 and a 1, I can't put a 1 in yellow. Because if this is a 4, that's a 1, that's a 1. But now 1 is in the same region as these, in the same column as these. So this just can't be a 4. These are the same. We agree with that, right? Because this cell, yeah, if these, yeah, this cell just, that doesn't work. So these two really are the same digit. We can ketchupings them. And so these two really are the same digit. We can relish them. So this is, and this is not a 5 anymore, by the way. And so these digits are never 2 for what it's worth, because either this is 2 or that's a 2. And so there is no 2 in here. Oh, we can place ketchup in a bunch of places exactly like we did earlier. So that's going to be ketchup. That's going to be ketchup. Oh, in this little region, that's going to be ketchup because it's a 1 or a 2. That's going to be ketchup because we need 1 in this region, and that's going to be ketchup. So this is a 1 or a 2. Okay, so all of these are 1, 2, 3, 4, not 3, 4, 5. That's 1, 2, 1, 2. Okay, so this certainly can't be 5 anymore because 5 and 5 would be too many. It can't even be 4 and 4 because 4 and 4 would be too many. And it can't be 2 because one of these 2 is a 2. So in fact, it just is 3 by AFK and ice powers combined. So that makes this always a 4 or a 5, which makes this a 6 and that a 6 by our earlier thing. Oh, sorry. 4 was actually still possible. Darn it. 4 plus 4 is 2 plus 6. You're right. Well, it's still not 2. It's still 3 or 4. Okay, so the green circle certainly over here. Yeah, I don't know that that's not green circle, unfortunately. So I can't quite do exactly the same Sudoku that I did the other way. Green circle in row 1. Can't green circle go there or like anywhere over here? So this number, at least I know, is 4, 5, or 6, right? Based on the possibilities here. Oh, the 4, 4 universe doesn't work. In the green is 4 universe, red is 1 because of Sudoku. And so although I agree that 4 plus 4 equals 6 plus 2, red isn't 2 in the universe where green is 4. So I think green circle is really 3. And this really isn't 6. So that is really 4 or 5. So we have that at least. So now we can place 3 up here because now 3 is not that. So now that is 3. And now that is 3 because we still need a 3 in here. It's one of the required numbers. And so now that is 3. And last but not least, that is 3. Let's see. This has been quite intricate, as it happens. Was I supposed to notice something else about the world where this was 2 or 4 or something like that? I don't think I could place this digit anywhere. Oh, I guess if this digit is 2, then it goes there, I suppose. Okay, this cell sees all of these digits and 3. So this digit is 4, 5, 6. And this digit sees all of these digits and 3. So this one is 4, 5, 6. Just by sort of weird coloring nonsense. And these two 4, 5, 6s are the same as these two 4, 5, 6s. It's being pointed out, so I can maybe like make these purple to remind us that these are the same as these. Let's see. If these are 2, 4, then these are a 2, 4 pair. Is that interesting? Oh, God, that doesn't work. If red circle is 2, then this is 4. But that's a problem, because this is 4 and that's 4. This being 2 doesn't work. Because of where this ends up. So these two can't add to 6, because if they do, they end up... AFK says that's not right. Oh, it just ends up meaning that there's no 4 in here at all, right? Because there doesn't have to be a 4 here, right? Because it could be a 5. Never mind. Okay, Garion points out the other 1, 2 shows up twice in these cells, so therefore this cell's not 1, 2, or 3, or 6. So this cell's also 4, 5. I agree about that. I wish I knew something about something more about whether these two 4, 5s were the same or not. I guess if they're different, these two cells are a 4, 5 pair. And if they're the same, then that's the 4, 5 that doesn't show up in this yellow realm. The green 4, 5 is in yellow. So these can't both be the green 4, 5. Why can't these both be the purple 4, 5? And do I know that the green 4, 5 and the purple 4, 5 are different? I don't think I do. I think the Sudoku is a little bit too messy for that. Oh, no. If these two are the same, they definitely show up in one of the green cells because of Sudoku. So so if these two are the same, they are the green 4-5, but they're not because the green 4-5 also shows up in yellow. Right, so they're not the same. These two are different. So we can have 1B green circle, 1B green X. And so that makes this green circle just by Sudoku. Makes this green X just by Sudoku. That makes this the other 1, 2. This cell now sees a 1-2 pair. This is the step that makes it worth having irregular Sudoku, because this sees that 1-2 by its region and that 1-2 by the column. So this is a 4. So red circle is a 2. Please don't take this from me. So that's a 1. So that is not a 4 anymore. So this is a 1. Let's see, this is not a 4. That's not a 2 anymore. That's not a 4. Sorry, not a 4. Okay. Oh, yes. X is 4. Yes, because of the arrow. So X is 4. So that's 4. So that's 5. And that's 5. Okay, so we can probably get rid of these now. So that has become 1 and 5. Which means that because we need a 5 up here, and that can't be 5, that's 5, and that's 6. That's 4, and that's 6, and that's 6, and that's 4. And that's 1. Let's hit mark for the rest. So 6, 5, 1, 4, 1, 5. Very nice, although I suspect that Selena's belief that somehow this was meant to be about the fact that 21 is odd, and we never sort of used anything remotely like that, sort of makes me suspect that perhaps we did not find the intended break-in. I am not 100% sure. But we did solve it, whether we found the intended break-in or not. Let's solve a Kinnison puzzle. So this is Renban, the puzzle. So we need to make sure every purple line contains a string of consecutive digits. In particular, this line needs to contain all the digits from 1 through 6. So if I ask where this digit goes in this box, it goes there, and where this digit goes in this box, it goes there, which tells me that these two are consecutive because they're on this line. And they're consecutive, so they must involve an even digit, and that number is neither 2 nor 4. So that actually tells me that these are a 5-6 pair of all things. Oh, and there's a given digit that actually will get me through that. So we've got that. So that is pretty exciting. So this number is a 1 or a 2 by Sudoku, of all things. So this is also a 1 or a 2 because 3 stuff. So these digits are a 4, 5, 6, except that one is not a 5 or a 6. So this is a naked 4. So these are 1, 2, 3. Oh, this was almost an Advent of Sudoku puzzle. That is cool. I know one of these is a 3, so I know this isn't a 3. These are 5, 6, just for the record. Also, Selena is pointing out that this digit needs to go in this box somewhere, and it needs to go there. So these two are the same, which means this is a 1, 2, or a 3. So it's certainly not a 3. It's a 1 or a 2. So we have that. So let's see. I know one of these two is a 3 still, which I keep looking at. Oh, these are a 4-5 pair. I probably should have written that in at some point. That would have been a wise thing for that is a thing a wise zeta would have written in. And so this is a naked single 1. So that is a 2 and a 2. I suspect I did the harder part of the puzzle first, and then did not actually notice the given digit. Basically, that's a 5-6 pair, which makes that a 4 and a 5. Also, there's a 1 on this, so there's not a 6. So that's a 5. Oops. That is a 6 and a 5 and a 6 and a 5 and a 6. That needs to be a 3. So that's a 1 and a 3. 3, 4, 5. That is a 6. 1, 2, 3, 4. That's a 5. That seems to be a 4. Let's see. One of these needs to be a 3, and it's that one by Sudoku. And this needs to be a 1 or a 5, but it can't be a 5, so it's a 1. It's a 2 and a 1. That's a 1. It's a 4. That's a 1 by Sudoku. That's 2. These are a 2 and a 3, it looks like, in that order. And these are a 3 and a 4, and it looks like in that order. Very nice. I'm always a fan of ye old Renban, so that is quite exciting. Alrighty, I do think I'm going to wrap up stream for today there. So thank you, everyone, for hanging out. It has been great fun, as always, to get through these puzzles. I will still be publishing Drop from last stream probably later today. So look forward to that, or grab it out of Sudoku testing. It's gotten a dozen solves. So if you want to solve it, you certainly can before I get to LMD. But anyway, I look forward to that, and I will see you all real soon. Huge thanks to everyone who supports the stream. If you want to support the stream, as always, you can click the dollar bill down at the bottom of the chat. And that will talk you through all of the various ways that you can do it. Probably by now it really does talk because they put AI in everything. But anyway, that will get you through things like, so you can become a member if you want to have the green name, and the green names are very cool. It gives you the Zach emotes, all that kind of thing. Or if you want to make a one-time donation or whatever, all of that is possible. Last but not least, let me thank our super supporters, our turbines who support at the top level. So that is Daniel, David, Franco, Nell, Nordy, Plonktime, and DDX. Thank you all so much. Thanks for watching. I'll see you soon. Bye for now.